I have wanted to get back into the multi-board project for a while now, but I've been sort of stuck with analysis paralysis, which is silly because it's a multi-board. You can always change it. So we're going to go into Fusion 360 and we're going to remix some things today. And so to start with that, I need a hook. I need the backside of the hook where it interfaces with the multi-board actually. So we're going to download that. And I'm going to combine it with an SD card adapter so that I can store some of my SD cards. So I'm just looking at some different options. This one doesn't have enough cards in it. This one's kind of interesting. That open back slot is interesting. I'm not sure if I want to use that. I'm leaning towards this one because I've used it before and there are different tightness levels. So I can, pick one, go with it, print it, see if it works, and if it's a little too loose, I can come back and make adjustments. So we're going to insert mesh, as we always do when we're trying to bring STLs into Fusion 360. Select from my computer, and we're going to start with the hook. So I'm going to grab that and get that into the workspace. And I always use center and move to ground. And I'm looking at it in the orientation. I want to go into document settings, and I can't while this dialog is open, so we'll do that in a second. Looking at its orientation in space, I already have kind of an idea of how I want this to work. So I'm going to change the orientation of that by using the handles. And now you can see the hook is standing straight up and down, which is what I'm looking for here. So we're going to bring that in, and then we're going to go double check the documents, make sure that capture design history is on, and you can see that because you have the design history at the bottom here. So we've got our hook, and now we're going to go into mesh and create face groups. Okay, and then we're going to go into modify and convert mesh, and that's our normal workflow for getting a part into Fusion 360. So now I can edit it, I can cut things off, and I can do what I want. This little feature here is about how far it should push in to the board. If I recall correctly, that's how Jonathan designed it. So I'm going to use that as a guide for how deeply I'm going to cut this thing, because I want it to be fairly close. So there's different ways I could do this. I'm going to start with an offset plane just because it makes it super easy to modify my depth of cut in the future. So we're going to get the offset plane and just kind of look at it and say, that's probably close enough. That's about where I want to cut it. I could cut it from the side as well, but I feel like the offset plane makes it easier to adjust. So we're going to drop a sketch on that offset plane, draw a box, finish sketch, super easy. Remember, we're going to bring the part in, and then we're going to modify the part by adding things or cutting things off. Here, we are cutting things off. So we're going to go straight to cut and grab that and pull it down. You can see I've made a mistake because that part I want to get rid of as well. That doesn't need to be there. So we're going to go back to the sketch. We're going to grab the side of the sketch and just move it over. I'm not even dimensioning anything. I'm just making adjustments, scooching things where it needs to be until I get what I want. So we have the part that's going to insert into the multi-board separated out, and we can now work on it. So time to insert mesh, and we're going to go back to select from my computer, and this time it's going to be the SD box fixed tight. So center, move to ground. I'm looking at it. I'm looking at the relative positions. I'm going to use these handles, and I want to look at it from the top to see how deeply it goes into the box. But we're going to grab these handles and move it and adjust it and tweak it until it's just where we want it. So we just kind of look around it and see how it sits. You can see that it's sticking through it. So just a little bit further down. That looks pretty good. It's not quite what I want. But there's additional, you can make additional fine adjustments to this if you really want. I think that just needs to be a little bit different. I want to make sure that there's room for that card to slide. That's too much. So we're going to go to numerical inputs, and we're going to make a more fine-tuned adjustment here. So by moving it, I can see that the X distance is moving. So I know that's the one that I want to change, and I just want to make them a little bit closer together. I'm trying to get that post more centered up in the box as much as possible. And that looks a lot better. I like that. That'll work. So here's our post, our box. We've now got the two in the relation that I want. I do want to make some modifications to the box as well. And my thinking is if I print it in this orientation, when it's installed on the board, it will capture the SD card, which I think I like But another way of doing it is flipping the opposite. So we're going to go ahead and take the SD card and fully bring it into Fusion so we can start editing it. So now you can see that it's changed colors and it's now an actual, part in the design history where I can start cutting things off of it and so on and so forth now that it's positioned where I want. So what I'm looking at is there's 4 slots by 2, so it's 8 slots in this thing, and it looks to me like it can fit 10. And I would like to have as much storage capacity in these things as possible. Why not? Why not add 2 slots? That would be cool. So we're going to start with the inspect tool, and we're just going to measure between these and make some notes so that we can duplicate the offsets. So the slots are 2 millimeters wide, and then just for the sake of knowing it, man, this thing is hard to grab onto. There we go. About 12 millimeters in that dimension. And about 2 millimeters there as well. Okay. So I could flip this. Yeah, I can invert how that's done. How deep are these? Or no, how wide is the center section? So that's about 1 millimeter. Okay. Not a problem. Not a problem. Just kind of sizing up and thinking through how I want to approach this. There's 2 different ways. I could cut it all down and then add up what I want, or I could fill it all in and cut down what I want. And I hope I make more sense in a second. So we're going to do 3 points because this is an STL, and therefore it's made out of a bunch of triangles, and every single triangle is a 3-point plane. So if you make a plane of 3 points, you'll perfectly match the triangle from an STL. So that tool is often useful for that purpose. So what I'm going to do is I'm going to fill in the space, and then I'm going to cut out what I want. So that'll fill in all these gaps. I could probably delete all of the faces and so forth, but anyway, so we're going to use P for project and project in the geometry that we want so that we can place the parts. So we're going to grab the line tool using our projection geometry and start filling in the sketch. This doesn't have to be precise at all because we're not doing a precision cut. In fact, the projection at the bottom is actually a little bit off, and it's not quite right. In order to just make this easy, what I'm going to do is do it in 2 steps. So first off, I'm going to set up the extrude to object, and I'm going to use this bottom so that it doesn't interfere with it. And yep, that's all the way down. That's one way to cut a pocket. But I don't want to cut the pocket. I'm gonna do the join. We're gonna go down that path, and then we'll cut in what we want. Yep, that's the way to do it. So now we go back to our sketch, and the depth of this has already been determined, right? So it makes it just a little bit easier. And like I said, notice how this is actually cutting under this, whereas if we cut out that would create all kinds of problems. But since we're building it up, we're filling in the gaps, it doesn't matter that those projections are not really what I want. So I can just, it's fine, I can live with it. So we're going to finish that sketch, and then we're going to go back into the extrude feature, and we're just going to add an additional part to extrude. And that's just fast, easy, quick way to get all that in, and now we've filled in those gaps, and we have that more solid space. Once again, if I wanted to, I could go in and simplify and delete a bunch of faces. I'm not going to mess with any of that. One of the cool things is, because I have the design history, you can move back and forward. So I'm checking the depth here, and it's a weird depth. So whoever designed this probably designed from the bottom up and not this dimension, because he probably didn't cut down like that. So, no big deal. So now I'm going to design a sketch onto that face. And my goal here is I'm inverting the pattern that was there. So where there was a rib, I'm now going to make a pocket. And where there was a pocket, I'm going to make a rib. So I've projected geometry, and now I'm just trying to create a center line and change that to construction. and we're trying to fill in these lines, and we want to make it a, since that is bisecting the center of the part, what we want to do is 2 millimeters off of this. And so I'm using one of my favorite tricks, which is using a circle, because this you can do a centered part and mirror and all that, but the circle most of the time is just faster. So you put the circle on the center part and then set out the outsides as tangent, and now you know that it's centered on that construction line and it's exactly 2 millimeters wide, right? And so I'm going into extrude, and this geometry must not be closed because I'm not able to pick up this other part of the geometry. So when I go into the extrude, it's not being successful. So I'm going back in and making adjustments to that to try to find where did I miss it, for lack of a better term. So we're going to delete that, add this back in, reapply our constraints, make sure that they're parallel, make sure that it's tangent, and then we'll see if we can extrude the sketch. Still didn't fix the problem. And sometimes that's the case. Like, it looks like it should be fine, but it's not. And that lower left corner, and the top doesn't look quite right either. So we can see the problem when we zoom in. So let's go back into the sketch. Oh, zoomed in way too much. All right. Zoom in. We're going to do a coincident. A little closer. All right. Let's try the coincident again. Just click, and there you go. Okay, so that part is no longer needed, so we can just get rid of that. And that looks like it's filled it in. It does seem to be, yeah, filling in. But let's take a look at this anyway. And that is not quite a right angle. Yeah, so let's go ahead and fix that while we're here. That looks better. Okay, so now we've fixed that the line was not closed, which was preventing us from extruding, and that should allow us to extrude it now. So let's go back into the extrude. We'll pick up our part, and that is the full face that we want. It's 2 millimeters wide, and it's kind of cool. You can see how this extrudes down into the part. So let's just reorient, and it was 9.2 if I recall, or 9.25, something like that. So it would be nice to be able to do an offset from the outside, but normally it's an offset from the starting position. So we're not going to mess with that. We're just going to cut down 9.2, but it needs to be negative 9.2. So let's go back into that and flip it and make sure that it's cut. Okay, so now we have a slot, our very, very first slot. Well, first and only slot at the moment. So what I'm going to do now is create a pattern, a rectangular pattern, of that feature, that extrude. So I've got object type features. I've selected the feature that I want, which is this slot. I'm going to select an axis for it to cut in, and that is cutting correctly. The other axis looks off. So yeah, set that to symmetric, and they're both set to 3. So where that is not what I want. That is coming in at like an angle, because the axis that I selected was that end, and I guess that end, yeah, could have a rotation component to it because of the face that's attached to it. So yeah, we're gonna have to ditch that axis. It's not working. Let's see if selecting here works better. We're getting somewhere. Still not quite right. Let's try again. Now that looks right. That's what I want. So that edge axis looks better. And yeah, okay. So let's flip these. And I want, let's see here. No, that's not the correct axes that I'm working on. That needs to be 2. Yep, and that one should be 5. And that needs to be symmetric. So now we're getting closer. And they're only 2 millimeters apart, so it's probably 4 millimeters center to center. So that looks right. And then this one, they were a millimeter separated. So those all look like they're where I want them. So overall, this is looking like what I was trying to get to, which is now we've increased the capacity. There's a total of 10, and the cuts look nice and clean. It really looks like it was a natural change to the original one. So we're going to do a Boolean join, combine these two parts, and now we have a single part that is now printable as a single part. We're not trying to do modifiers or any of those other tricky things, so we just need a single, clean, entirely joined part. We have our reworked center section, so we have space for more SD cards here, and all that we've done is flipped what were slots and turned them into ribs and vice versa. So we're going to go ahead and save the file. Finally, I should have done this, I don't know, at the very beginning and not at the very end. Oops. So, but all right. So we've got that saved out. Just looking over the part, everything looks like I want it to. Looking for any kind of issues that'll cause printability problems. We want to print it up standing on its end. That's how the original was designed, and we have a single body because I've joined the two bodies together. If you want to do an STL, you do save as mesh from there, but we do not want to do it as an STL. We want to do it as a step file, so we'll go to export, and you have to scroll down a little bit to get to step files. So we'll go ahead and export that as a step file and get that over to our slicer. I recorded this a little while ago, so that was when I was using Bamboo Lab. I switched over to Orca Slicer. I've got a video on that. Check out the cards. And I'm really happy with Orca Slicer. Since we got the part into the slicer, I always like to look around the part and look for any kind of problems, anything that I would have missed, any issues that need to be addressed before you commit to a print. I'm looking for, overhangs and stuff like that. The overhangs and bridges and things on this part should be fine, and there shouldn't be any issues because of the orientation. So just checking to make sure that there's no parts on the build plate, and go back into slice the part, and then after slicing the part, I like to look at the preview and look layer by layer for any kind of problems, things that aren't going to print well. And those bridges shouldn't be an issue because they're tied on both ends, so even though it is a bit of a steep overhang on this part, it shouldn't be an issue because of the overall part geometry and the fact that they're not just overhangs, they're also bridges. So none of those should cause an issue, and it should print well. And then the stud on the end that plugs into the multiboard will also print well because it's on the top side of the part. Even though that stud was originally designed to be printed on its side, it shouldn't present any issues or problems moved into this orientation. Especially because strength is not such a big deal for this part. So I prefer cubic, and so I'm just looking at the print time, deciding whether or not more infill makes sense or not. If it's not much of a penalty, in this case it really doesn't make that much of a difference. I'll just up the infill just a little bit. It shouldn't have a huge impact on the outcome. So we'll just reslice that. It's pretty close. It's a few minutes different. So we'll go with the higher infill density, and we'll go ahead and print this part out as it is. And then after getting it in hand, see how we like it, see how it feels. So kick off the print in Black PETG, and there you go. So here's the printed part, and this is the tight STL. And that lid's pretty loose. It won't be a problem on the multiboard because it just plugs in, but I went ahead and kind of redid all the steps that I showed you with the tighter STL, and I definitely like that better. The way that lid holds on just feels a little bit better. Not that I think this one's going to fall off. It works. It's just a little bit loose. So I really like it, and this is going to be how I store my microSD cards. You can just stick them on the multiboard, and then if you want them or need them for any reason, you know exactly where they are. You just grab them and pull them off. I really enjoy these kind of remixes and designs, so I'm going to be doing a lot more of those in the near future, I want to fill up this multi-board. I'm tired of looking at it, and I just got to get stuff on there, and then I can rearrange it and readjust it. That's the whole point of a multi-board. So why am I overthinking it? Because I can overthink anything. So if you enjoy this type of content, I hope you subscribe and join me again in the future. And I hope you enjoyed watching, and even better, maybe picked up a few tips and tricks along the way. So I hope this helped, and thank you for your time. Let's try it again. Let's pause, go. We've increased our capacity by, I want to say 20%, but I'm making up statistics on the fly. I shouldn't do math in public. That's a bad idea.